We're going to be talking about writing linear equations. And this is useful when you get to calculus. When you talk about writing the equation of a tangent line, you do things exactly like these examples we're about to look at. But before we do that, the type of examples that you see in calculus are like this very first one. We will talk about these other two types, but we're going to start off with one type, which is just when you're given 1 point and a slope. Now, we're going to be asked to find a linear equation. And one of the main formulas we're going to be using is this point slope form. So y minus y sub 1 equals m times x minus x sub 1. Because in all of these problems, for any equation, you need a slope and a point. And in each one of these, you're given a point and a slope. The second one, you're given 2 points, but if we remember the slope formula, which I'll put it here. If we remember the slope formula, it is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that would allow you to find the slope here. In this last one, you're given 1 point and a linear equation. But you can't forget the point slope intercept form. Y equals mx plus b. Because if we're given a linear equation, I can get the slope if I put my equation in slope intercept form, meaning isolating the y, and then the m is my slope. So in each one of these, the first one is very explicit with the point and the slope. But the next two, it's explicit with the points, but not with the slope. For the second one, you would need to use the slope formula. For the third one, we'll need to use the equation, the slope intercept form. And some special cases where we're not going to use the point slope form. So for all of them, we're going to use the point slope form. These are just additional formulas for these two specific cases, but you'll still use the point slope form. The only time you don't use a point slope form if we're talking about a vertical line and a horizontal line. Because we already know if we're doing a vertical line, all we need to do is find an x coordinate. Because all the equations of vertical line is when x is equal to a constant. So I just need to find the x coordinate of the point that's given. Right? Each of these give a point, and they're going to have the x coordinate. For a horizontal line, all I need to do is find the y coordinate from the points that are given. So without further ado, let's read this question. So we're going to find the equation of a line. So again, we're going to use the point slope form unless it describes a horizontal and vertical line. Passing through the point, having slope -4, write your answer in slope intercept form. So there we can see case 1. There's no talk about horizontal or vertical lines. And when we talk about horizontal and vertical lines, we also know that because there's an implicit way of it asking for a horizontal or vertical line. And that is if they tell you that the slope is undefined. Because the slope of all vertical lines is undefined, and the slope of all horizontal lines is 0. So if any of these situations occur, you know you can just find the x coordinate or find the y coordinate. All right, but this one doesn't have that. I'm going to use my point slope form. And since I already have my point, so here's my x, here's my y, I'm just going to plug everything in. So y minus, and to plug things in, I like using parentheses. My slope is -4, or here. I usually like to do this. I set up my parentheses beforehand so that when I plug in, my y is 3, my slope is -4, and then my x is 2. And then I want to write it in slope-intercept form, which is y equals mx plus b. Again, and I'm not doing that because I have this situation. I'm just doing it because it says here, write your answer in slope-intercept form. So y minus 3, and then I'm going to distribute this -4. So it's going to be -4x plus 8. I'm going to add 3 to both sides. Y is going to give me -4x plus 11. And I'm done. That's the equation that passes through this point and has a slope of -4. And you can graph it to see that that's true, but for the sake of time, there is our answer. Let's do a couple more examples. So these dots are just implying find the equation of the line passing through this point having slope -4. So same thing, but now I'm switching the signs. So because it doesn't say anything about a slope of 0, slope that's undefined, or horizontal and vertical lines, once again, I'm going to use my point slope form. But this time I'm just going to put all my parentheses. And once again, -3. And it's really important in this example that you put those parentheses. Because hopefully you remember that a negative times a negative is a positive. And then these two negatives also become positive. And I'm going to do that before I distribute this -4. Let's bring it over here. It's going to be y plus 3 equals to -4x minus 8. And lastly, I just need to put in slope-intercept form if possible. I'm going to subtract 3 to both sides now. That cancels, and that leaves us with y is equal to -4x minus 11. And there is our equation. You can pause the video at any time and try these examples. Same thing with the next one. Y minus equals m times x minus x sub 1. My y is -2. My slope is -2. And my x is 3. But I'm going to take care of these negatives first. So that's going to be y plus 2 is equal to, and here a negative times a positive is negative. I'm just going to distribute this. I didn't distribute on the last one because I wanted to take care of those two negatives first. That's going to be -2x plus 6. And then I just need to move this 2 over to put it in in slope-intercept form. By subtracting 2 to both sides, that will leave me with y is equal to -2x plus 4. I just didn't show it, but it's just subtract 2. Subtract 2, that makes that into a 4. Now this one has a really ugly point, but then it says slope 0. Now hopefully you can recognize, like, wait, I remember something about slope 0. Right? Where I said, if you have slope 0, that's going to be a horizontal line. That means my equation, I don't need to. You can still use the point slope form, but it's so much quicker if you just use the slope-intercept form. I mean, this y equals c, because all I need to do is look at the y coordinate, and that's my answer right here. So I would literally just write y is equal to 32 over 15, and that's my equation. And it's in slope-intercept form because the y is isolated. Remember, slope-intercept form is y equals mx plus b. Sure, it might not have x, but the y is still isolated. And once again, this says slope is undefined. What's the equation of all undefined slopes? Is x equals a constant. For 0, it was y equals a constant. So all I have to do is look at the x coordinate. And my equation of the line is going to be x equals 0.32179. I know it looked tricky with that, but if you notice, I didn't really pay attention to this. I just looked at the slope, and then I just copied the x coordinate. And that is my equation. Now, let's move on to what happens when we have 2 points. So here, write the equation of a line passing through the points here. But if you notice, nothing talks about horizontal or vertical lines. Now that might get a slope of 0 after you find them, but that means I'm still going to use my point slope form. Now, in terms of point, both of these points are on the line, so it doesn't matter which one you use for plugging in. I could literally set up my formula, and I could already start plugging in. I'll just pick the nicer one. So y is 2, and then x is -1. I just need to find my slope now. But to do that, I'm going to need I'm going to do it here on the side. I'm going to need my slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, you don't have to get this. This is just notation. This is just saying a point. Doesn't mean that you need to put the same exact point here. The idea is you have to subtract the points that are, when you put the points in, you want to make sure the ones that are directly above each other are coming from the same ordered pair. So I'm going to start with the first ordered pair. I'm going to put the y up top, which is -6. I'm going to put the x at the bottom, which is 4. And then I'm going to subtract and put this in parentheses because I have a negative. My y is 2, and my x is -1. Well, now in the numerator, that's going to give us -8. But in the denominator, don't forget, these two negatives become positive. 4 plus 1 is going to be 5. And there's my slope. It's going to be -8/5. Once again, these two become positive. And I will distribute through, which will give me y minus 2 is equal to -8/5x minus, because a negative times a positive is negative. And since 1 times 8/5 is just going to be 8/5. And to put this in slope-intercept form if possible, all I need to do is add 2 to both sides. But that part here, to be able to add them, we need to add fractions, meaning I need the denominators to be the same. So I'm going to multiply by 5 here, by 5, because what I'm really multiplying by to this, because 5 divided by 5 is 1. And anything times 1 is going to be that thing you multiply by. So that's going to leave us with y is equal to -8/5 x minus 8/5 plus 10/5. And now I can just, now the denominators are the same, I can combine the numerators. So -8 plus 10 is going to leave us with y, let me do it in red, y is equal to -8/5 x plus 2/5. And there is my equation. You do the same with all of these. So I need my point slope form. Yes. And I always like putting the parentheses and then just plug in. I like this first one better. Or let's put the second one. So the y. But sometimes this one will be better just because it's all positive, so we don't make any mistakes with the negatives. But we should be able to do both. Again, it doesn't matter which one you plug into the point slope form. Both of these are getting passed through. So they're both on the line. So they're both okay to use. But now I need to find the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So like I said, it's just make sure they're from the same ordered pair. So the first one is a 4. And the x is a 2. I'm going to subtract by the y is negative 3. And the x is negative 1. So these two are going to become positive. These two are going to become positive. 4 plus 3 is 7. 2 plus 1 is 3. So now there's my slope, 7 over 3. Don't forget these two become positive. So do these. And I'm going to distribute this through to give me y plus 3 is equal to 7 over 3. X plus, and then 1 times 7 over 3 is just going to be, 7 over 3x. It's going to be plus 7 over 3. And then I need to subtract that 3 to both sides. But once again, I need to have the same denominator. So that's going to give me y is equal to 7 over 3x plus 7 over 3 minus 9 over 3. And that simplifies to y equals 7 over 3x plus 7 minus 9 is, we keep the sign of the bigger number, it's going to be negative 2 over 3. And that is our line. Again, if you need to see it again, just rewind it and then watch this part. But once you see them, you kind of get the hang of them. So once again, let's just start with finding our slope first this time. Because we know we have 2 points, we need to find the slope. And then we'll plug in the point slope form. So this is a little weird, but just make sure the very first one, again, your y and your x have to be directly above each other. So that's going to be 2.03 over negative 1.24. I always like to put it in parentheses because when you end up getting negatives, the negatives end up becoming positive. So the y here is 2.03 and the x is negative 2.49, which again, those two become positive. But if you notice here in the numerator, take a look. 2.03, 2.03, they're the same. What happens when you subtract two numbers that are the same? You get 0. And then it doesn't really matter what this ends up being down here. Because whatever number that is, we know that 0 divided by any number is always going to be 0. Let me move this over a little bit. It's always going to give us 0. But then, hopefully that reminds you, wait, if the slope is 0, that means this is a horizontal line with y equals a constant. That means I only need to look at the y-coordinate, which makes sense, because look, the y-coordinate's the same for both of these. So my equation is just y is equal to 2.03. That's all I need to do. Could I have done all this, do the slope form? Yes. But that is so much faster and allows you to think critically and actively as you're doing these problems. So again, watch out for those. And that would have been the same if if the x's were the same, you would have had an undefined slope, and that would be when x is equal to a constant. And our third and final case is looking at when you're given a point and a linear equation. So, but these type of examples involve this idea of being parallel and perpendicular. Now, parallel, remember, are just two lines that never intersect each other. Like this. Two lines never intersect. Now, that's great visually, but on an equation, how do I know that they don't intersect each other? Well, they need to have the same slope, right? They kind of need to have the same slant to them, whether it be flat, down. They need to have the same slant. If they don't have the same slant, then they're definitely going to intersect each other. But what stops them from being the same line? They need to have a different y-intercept, and that creates that separation between them. Now, what does it mean to be perpendicular? Well, that's when you have two lines that do intersect each other, but they intersect each other at a 90-degree angle. So that point of intersection is 90 degrees. Now we can see it visually, but once again, how does that happen on an equation, right? On y equals mx plus b. Well, the slopes have to have opposite sign, so that's one thing. So different than parallel, right? Same slope. And second thing is the slopes have to be reciprocal of each other. That means if one slope is a over b, the other one's b over a. So if you notice, in a lot of these, to be able to tell parallel and perpendicular, a huge thing is the slope and the y-intercept. Only if there was an equation that we can write that gives us the slope and the y-intercept perfectly. Hopefully you guessed it. Slope-intercept form is going to become super vital in these examples. But we're still writing or describing or finding a linear equation. Nothing here talks about horizontal or vertical. So that tells me I'm going to use my point slope form again. So that's going to be, I'm already going to start putting my parentheses. I have my point, which is the y is 1, the x is negative 4. I just need to find my slope now. But how am I going to do that? I'm going to get it from my equation. Remember, all I need to do is write this equation in slope-intercept form. So that means I just need to isolate my y. I'm going to do that right here. I'm going to subtract x to both sides. I'm going to write the x first. It's going to be negative x plus 3. Now I'm going to divide 4. Remember this trick. You're supposed to divide to the entire right-hand side. But to save some time, I know that's going to end up splitting to dividing to each one. So I'm just going to do that for now. And that's going to give me y is equal to negative x over 4 plus 3 over 4. Now, this says that I want the lines to be parallel to each other. So that means I need the exact same slope from here. So first, I need to identify what the slope is. So I know my slope. Now you have to be careful because it has it over this 4, like this, and the negative 1 up front. That you're going to sorry about that. you're going to look at, remember the slope is the entire coefficient of x. So don't just think, oh, the coefficient is negative. No, -1. No, there's this 4 here. So it's -1/4. So that means here I need the parallel slope. So I always like to just write under, even though it might seem redundant, I need the same slope. But it helps me distinguish that this slope came from the given line, and this slope is the one I'm using for my new line. And I know to be parallel, you need different y-intercepts, but that's going to happen naturally because you're using a different point. So here we go. These two negative become positive. I'm going to distribute here. That's going to be y minus 1 is equal to -1/4 x. And then it's going to be a negative times a positive. It's going to be -1/4 times 4. I wanted to write it out because if you notice, 1/4 times 4, how do I multiply fractions? Straight across. So I would put 1 under this 4 and multiply across. That's going to give me 4/4, which is just -1. Then I need to add this 1. And the moment you put in that slope, you have found the equation of the line that's parallel to x plus 4y equals 3. But all we're doing here, it does say to write the line in slope intercept form if possible. So after this step, we are just looking to put it in slope intercept form. And that leaves me with y is equal to -1/4 x. And then the -1 and +1 cancel. And that leaves me with my linear equation. That's parallel. And if you notice, the y-intercept here is 0, 3/4. This one, 0, 0. And like I said, at any point you can try to pause these and try to do them. So let's do the exact same problem. But what would happen if it was perpendicular? Well, looking at this line, we know the slope of the line was -1/4. But let's not forget, I want the line to be perpendicular. So my perpendicular slope is going to be opposite signs. I mean, this was negative, the next one's positive, and then it's going to be 4/1, which is just 4. And then nothing here talks about horizontal or vertical. Slope 0, undefined slope. So it's going to be like this. X minus, and then we're going to plug in our point again. The y is 1, the x is -4, and my slope is 4. And these two negatives become positive, and I'm going to distribute to that. So it's going to be y minus 1 is equal to 4x plus 16. I'm going to add 1 to both sides. That leaves me with y is equal to 4x plus 17. And then we have these next two, and these are going to be quick because if you recognize it, I want a point that passes through this point but parallel to y equals 5. Now, if you remember, when y is equal to a constant, that's a horizontal line. So if I want another line that's parallel to it, I need another horizontal line, right? But if I want a horizontal line, all I need to look at is the y-coordinate. So that means my answer is y equals c. I'm just looking at the y-coordinate. Now the next example is I'm looking for something that's perpendicular to this given line. But when x is equal to a constant, that makes a vertical line. So what's perpendicular to that? A horizontal line. Once again, for horizontal, all I need is y equals c. If I needed a vertical line, it would have been x equals c. But all I need to do is look at the y coordinate, and that's going to be y is equal to 72 over 45. And I like these examples this way because it makes the point seem like this problem's going to be really difficult. But if you analyze it and pause and actively understand and pay it as you're working through it, hopefully you recognize that you can do this problem. Oh, I just put x equals c here. It's supposed to be x equals 10. And that will give you your answer. So try these. This you can rewind it. If I went too fast, let me know. But these are the 3 types of writing linear equations. And again, the main one you use a lot later on is this first one, which was really nice. The one we probably did the most work for. But, okay.